Okay, now big idea number 3 is this. Proportions involve multiplicative rather than additive comparisons. Multiplicative rather than additive, which means equal or equivalent ratios result from multiplication or division, not from addition or subtraction. Okay, so we can go back and actually look at, if we go ahead and go look at this lemonade problem. Let's see, go back and look at the lemonade problem. No, okay, go back and look at okay. Well, anyway, let's talk about that lemonade problem. So remember, we had our we had 6 lemons, right? We had 6 lemons for every 4 cups of water. Remember, 6 lemons, 4 cups of water, and so that put our our ratio at 6 to 4 lemons to cups of water. Okay, and we went ahead and we asked the question, well, what about 18 lemons? If I had 18 lemons, I wanted to squeeze them all and make as much as I can. What would I do? Remember, we came up with 12 cups of water. And the way we got there is we figured that to go from 6 to 8 would mean to multiply by 3. And this is this whole multiplicative part of the equation, okay, of proportions. So therefore we had to do the same with 4. We multiplied that times 3 and we got 12. Okay? We could move the other way. Let's say we had, okay, so well, let's just move, let's get rid of that right there. Let's say that we only had 3 lemons. Okay, I'm making this pretty easy, just to keep it nice and neat. Okay, but again, with a calculator, you could do, you could make it, you could do anything really. So 3 lemons. Let's say if I had 3 lemons. Okay, what would I do? How many cups of water? Okay, so you can look at it. If I compare my 6 to 4, if I had only 3, that means I only have half of the 6, and I could either divide 6 divided by 2, okay, equals the 3, and then 4 cups of water divided by 2 equals 2, okay, so I would have my 3 to 2, okay, which is even a more precise ratio. Honestly, it is the in those terms, it's the lowest termed ratio, 3 to 2. Okay, but I can move either by multiplication, I can move up, or I can move down in a sense with the numbers by division. Okay, but the truth is 6 to 4, 18 to 12, 3 to 2, they're all the same. They're all equal or equivalent. Okay, and the way I get to equivalent proportions is, or equivalent ratios, is I use multiplication or I use division. Okay, not addition. Because if we looked at addition, let's say we have 6 to 4 as our ratio. Okay, let's say if we added 2 to both sides, plus 2, and then plus 2 here, 8 to 6. Okay, 8 to 6 is not equal to 6 to 4. They are not equal. Okay. All right, you can't just add. Okay, you multiply. If you had 8 here, we could figure that out. We could figure it out for 8 lemons. We could do the division or the multiplication. Okay, but you can't just solely just add. Okay, so we'll put a big X over that. Okay. All right. So big idea number 3. Okay. All right. Okay, let's look at big idea and let's do a few problems using big idea. Okay, so my goal here is to guide you guys to begin to think, if you aren't already, multiplicatively versus additively. Okay? All right, so let's go ahead and look at a couple of problems to look at them multiplicatively. Okay. Now, problem 1 is this. 2 weeks ago, 2 flowers, A and B, were measured at 8 inches and 12 inches, respectively. Okay? Today, flower A is 11 inches. Flower B is 15 inches tall. My question to you is, which flower grew more? Which flower grew more? I want you to just think about that for a little bit and jot down some ideas in your journal, and then start. Just pause, jot some ideas down, and return. Okay, so here we are back again, and again the question was, did flower A or B grow more? Okay, so let's just let's create a chart of some fashion here. So we have flower A. Okay, we have flower B. Okay, now flower A ended up at 11 inches tall. Okay, do that. 11 inches tall. All right. Flower B is now 15 inches tall. Okay. All right. 2 weeks ago, A was 8 inches tall, and B was 12 inches tall. Okay. So if I go ahead and subtract away here just to see the growth, okay, what we have now is we have that A grew 3 inches and B grew 3 inches. So if your answer was they both grew the same, I'm not going to tell you you're wrong in that sense, because in one sense you are correct. But the fact that they began as different sizes, and grew the same number of inches. Okay, I want that to start telling you something, kind of change your idea about the term more. Okay, because if we go ahead and look at 3 inches of growth, okay, and then look at it compared to what they started at, okay. I'm sorry, I actually put, I should probably just correct this here, because I really didn't want to look at this size. This wasn't the beginning size. It's actually the ending size. I should probably, let me do this correctly. I'm going to end, begin. See, it pays to be neat, not be sloppy like I'm being here. I'm trying to fit this into 15 minutes. I'm never going to do it. But anyway, and then this is growth. Okay. We already said the growth was the same. I'm sorry. So now let's go ahead and look at the beginning size. That started out as 8. This started out as 12. And then they both grew 3 inches. So 3 compares to 8, and then we're going to compare 3 to 12. Okay? Because when it started out as 8, it grew 3 inches. Started out as 12, grew 3 inches. So what we can look at then is we can say that 3 over 8, or 2/8, compared to 3 over 12, or 3 to 12, because when you look at a ratio in this term, the ratio and fraction are are similar numbers. Okay, we could tell right away, knowing what we know about fractions. Hopefully, when you have eighths and twelfths, again, that smaller denominator is going to be a bigger piece. Okay, and we could also look in terms of let me just make myself a little more room here. Need to make more room. I think I might have some on the next slide, but I'm not quite sure. So anyway, we could also look in terms of fractions, and we know that fractions are division. Okay, so if I do 3, divided by 8, I could find my percentage of growth. Okay, and I know that, what is that going to be, 20, 24, 60, so about 37, 38, about 38%. So if I look at flour A, it grew about 38%. And then if I look at 3/12, hopefully you can see that also as 1/4. Okay, it's a equivalent fraction there, and 1/4 is 25%. Okay, 1 divided by 4, 3 divided by 12. So B grew 25%. So in terms of proportionality, A, in fact, grew more. Did anyone think of that? Okay, so here's what, these are kind of notes for your parent teacher, but what may have transpired, and what does transpire quite often, especially when children are just beginning this study, is that they were, students will correctly identify that both flours grew the same 3 inches, and in one sense of the word more, that is correct. In terms of proportionality, that's what I want to just underline, and in terms of proportionality, they will most likely need guidance to notice that A grew more relative to the size at which it began. And that comparison would be 3/8 is greater than 3/12. Okay? Let's move on here. 4 minutes. And again, we can look, and if we still need this at this point, we could look at 3/8 and 3/12, and if we look in terms of their size, we don't want to do that. Get rid of that. I want the pen. So 1, 2, 3, it's not going to be right, 4, 5, 6, 7, 8. Okay, there's 8. And if I have 3 of those, I have that much. Okay, now if I have 12ths, oh boy, so let me see. That's 4ths. Oh man, 8ths. Oh, it's not going to be good. 9, 10. Oh, not good. Wow, well, you can see. I know, it's terrible. I should have done it that way. Hold on, do that over again. I'm going to do it over again. Do it the right way. Okay. Yeah, I've gone like this because I want, common factors. So 3, then 6, then 12. Okay, so now I have 12ths. All right, if I color in 3 of those, see them right there. And it's pretty obvious that that is a bigger chunk than that. Okay, so 3/8 is going to be more. All right, I'm sorry, that was kind of a weird tangent. But anyway, I'm going to move on here. And this is probably going to be the end of... actually, I'm going to stop right here. And we're going to get back to problem 2 in the next video segment.